Hi, my name is Dia Patel. I'm a 7th grader at Dirksen Junior High School, and this is my nail polish experiment for the science fair. The purpose of this experiment is to see which nail polish would last longest so I know which one to apply more often. Which brings me to my question, which nail polish lasts longer, matte or shiny? My independent variable is the type of nail polish I'm using. My dependent variable is how long each nail polish lasts. My control variable is how many coats I put on. And my hypothesis is if I put matte and shiny nail polish on at the same time and go through with my day, that matte nail polish will last longer because it's thinner, which makes it last longer. Here are the materials I used. This is the matte nail polish for trials 1, 2, and 3. The shiny nail polish for trials 1, 2, and 3. My first step was to gather all my materials and take off any current nail polish I may have on. My second step was to paint each nail, making sure it's consistent and even. My third step was to repeat on the other hand, making sure it's even and also consistent. My fourth step was to let the nails dry completely before using my hands again. My fifth step was to check my nails every day at a specific time to see if either one was chipping. My sixth step was to repeat steps 1 through 5 for trials 2 and 3 for accurate results. Here are the pictures. These are my nails at the beginning of trial 1 and at the end of trial 1. Here are my nails at the beginning of trial 2 and at the end of trial 2. Here are my nails at the beginning of trial 3 and at the end of trial 3. For trial 1 for shiny nail polish, it took 3 days before the chipping started. For trial 2, it took 4 days before the chipping started. And for trial 3, it took 3 days before the chipping started. So on average, shiny nail polish takes 3 days before chipping. For trial 1, it took matte nail polish 4 days before the chipping. For trial 2, it took 5 days. And for trial 3, it also took 5 days, which on average made 4 days for the matte nail polish. Here's everything I just said on a data/visual form. In conclusion, I learned that matte nail polish can go at least 4 days without chipping because it's thinner than shiny nail polish. My data supported my hypothesis because shiny nail polish start chipping sooner than matte, but my source of error was I did not check to see if my nail growth affected the results, which could have maybe changed the results. I can further extend this experiment by trying different brands of nail polish and seeing if the results differ from these. I'd also like to give credit to my teacher, Mr. Ackerdy, for explaining the instructions to me when I felt confused or overwhelmed. I also like to thank my mother for providing me with the materials I needed to continue this experiment, and I'd also like to give credit to myself for committing and not giving up on this project. Thank you, that is all.
Well, for my presentation, I decided to see if I could change the color of plants using blue gel and blue dye. This one was the blue dye. As you can see, not color change. There was no color change at all, really. For the one with the gel, although, there was some slight color change. I'm not sure if you can see, but right there, the dirt around it, though, that was the biggest change out of everything. And even though the plants did not turn as blue as I had hoped, something did change. So I am actually kind of happy about that. Before I had extended the time, there was not too much difference, although I did see some tiny spots of blue, and that's why I asked if I could extend the time of me working on this project. But after a while, it kind of stopped changing. The areas where it mostly changed color was areas where it was more or less white. You can see right there, you can see the lines. You can see that they are, you could probably, maybe, I'm not sure, see if they had changed, but I'm not sure if you can see it. But for this one, well, the dirt is, well, slightly changed. The plants did not change at all, really. But other than that, yep, that kind of concludes my my presentation. I'm sorry, I'm kind of I feel very uncomfortable. I'm sorry if I took a bit too long trying to explain. But yeah, thank you so much for listening and me for being chosen as one of the people for the city or state or no, not state or for the city. But yeah, thank you.
Hello, my name is Gerardo. Today we're doing the science fair project of which water freezes faster, cold or hot. I just want to thank the people that helped me, my aunt, my dad, and my mom. So first what you have to do is get the materials, which are
2 cups, thermometer, the freezer, and the timer.
It could be, a regular timer, a clock, but we're just using a phone clock. So yeah. So what we have to do is get 1 cup, same size. Have to be the same size. And 1 cup is gonna be hot in the water.
We're gonna wait for the water to be hot.
This is my auntie. And now the other one cold. And now we gotta measure the water. We measured it and it's about
80 degrees.
80 degrees for hot and cold.
Like 25.
25 degrees cold. And now to put it in the freezer, which is about 20 degrees, we checked it. And we're gonna put the 2 cups. We're gonna wait a while. I'm putting it in the freezer right now. And we're gonna wait about like 15 minutes.
We're gonna check our timer.
We're gonna check our timer, so we're gonna put it. Make sure you put it, don't forget. And we'll see you in the next episode.
Hi, my name is Keyshawn Turner, and today I'm going to be talking about my science fair project. So my science fair project is which nail polish lasts longer, shiny or matte. So my ingredients was 3 colors of shiny nail polish, 3 colors of matte nail polish, and some fake nails and tissue or cotton swabs to take the nail polish off. So the first thing I did when I got home was put the nail polish on each put the 3 color nail polish on each nail and waited an hour to wipe to take the nail polish off, and then waited 2 hours, then 3 hours. As my graph shows, matte nail polish lasts longer than shiny nail polish. And I did this project because it's different from any other project, and it was fun to do it. So, bye. Have a nice day, and hope you did.
Hello, My name is Ozio Lara, and today we'll be talking about my science fair presentation. My science fair presentation is called "What Liquid Makes Ice Last Longer." My acknowledgements. For my acknowledgements, I would like to thank the school district for signing this science fair, which will turned out to be really fun. I would also like to thank my aunt who let me borrow her vinegar. For my abstract, the main purpose of the experiment is to find out what makes ice melt slower. The procedures of this experiment were to grab a plate, place the liquid over the plate, put the ice with the plate in the liquid, and start my timer as soon as it touches the liquid. Then write my results. The results turned out to be that water makes ice melt faster, then comes vinegar, and soda was the slowest. In my conclusions was that my hypothesis was not correct, and soda was the one that melted slower. The question I was wanting to answer is what liquid makes ice melt slower. For my hypothesis, I put if I place an ice cube in water instead of soda or vinegar, then the ice cube will melt slower. For my background information, the topic is to answer the question what liquid makes ice melt slower. Another point is if I want a cool drink to stay cool for it should be a soda. The point of why I did the topic was to want to see if I was correct if water makes ice melt slower. For variables, my dependent variable is the time the ice cube lasts. Well, my independent variable is a liquid used for experiment. The controlling variables are the temperature, the size of the ice, and the plate size. For my materials, I use 9 ice cubes, plates, 1 timer, 1/4 of a cup of water, times 3, 1/4 of a cup of vinegar, times 3, 1/4 of a cup of soda, times 3. My procedures were obtain all materials, place 3 on a table, take out 1 ice cube and place it on the plate, pour 1/4 of water into it and start the timer. Repeat the last 2 steps twice. Repeat the same steps with the vinegar and soda 3 times. Document my answers. Make a graph with my findings of the experiment. Correct or confirm my hypothesis was correct or wrong. Check and state my errors and answer the rest of the questions. My results were that trial 1, soda was the one that melted slower. Made the ice melt slower. Well, water was the one that made it melt faster, and vinegar being in the middle. The same thing I can see the same thing for trial 2 and 3. In the average, water lasted 1 hour and 14 minutes, vinegar 1 hour and 17 minutes, and soda 1 hour and 33 minutes. My chart here explains how the water was below 1 hour and 15 minutes. Vinegar was like in the middle of 1 hour and 20 minutes and 1 hour 15 minutes, and soda was between 1 hour and 35 minutes and 1 hour and 30 minutes. In conclusion, my data did not support my hypothesis. A source of error was on the second water trial. I forgot to put the timer, so I had to redo the trial. I learned that ice lasts longer in soda than in water. I know if I want a cool drink that lasts cold for a while, it should be soda. Anyways, this is then for my presentation.
Hello, my name is Daniela Macias, and I will be talking about my science presentation on water absorbency. Acknowledgements. I would like to acknowledge my mom, Miss Foxworth, and myself. Abstract. I am making this project to find if all paper towel brands are the same or are some worth the price in advertisement. I'll be laying out 3 towels of one each brand, Bounty, Sparkle, and Brownie, and I will then drop exactly 3 water droplets on each and see which one holds the most liquid. Bounty held most water of all 3. Question: do all paper towel brands have the same water absorbency? Hypothesis: if 3 water droplets are dropped on each paper towel brand, then Bounty will absorb the most liquid. Background information: each brand claims that their product has strong durability when it comes to water. All 3 brands have different textures: rough, soft, and bumpy. The costs for all brands except Bounty have a lower price. Variables: dependent variable, the paper towel brand. Independent variable, the paper towel brand. Controlling variables: the layering of paper towels. 3. The number of water droplets. 3. The type of water. Materials: paper towels, Bounty, Sparkle, Brawny, syringe, 4 water, water. Procedures: first, obtain all materials. Second, label each experiment session with brand names: Bounty, Sparkle, and Brawny. 3. Place every 3 layers of paper towel brand on a flat surface, separated. 4. Put syringe filled with water on top of each experiment. 5. Squeeze the syringe to let out exactly 3 water droplets on each brand. 6. Lift up each experiment and search which held the most absorbency. 7. Repeat 3 more times to ensure accuracy. 8. Record results on your data table. 9. Clean up your workspace with a rag if there is any water on your surface. Results: on trial 1, Bounty 100%, Sparkle 97%, Brawny 92%. Trial 2, Bounty 98%, Sparkle 90%, Brawny 89%. Trial 3, Bounty 98%, Sparkle 92%, Brawny 87%. Average: Bounty 99%, Sparkle 93%, Brawny 89%. Graph: absorbency data. Absorbency: brands. Bounty held at least 99%. Sparkle, it's held at least 80. Wait, no. Oops, sorry. Around that area, and Brawny held less. Conclusion: I learned that Bounty holds the most water absorbency. Their advertisement is spot on for the product they are selling. My data supported my hypothesis with data and observations. My sources of error were measuring the correct amount of absorbency and doubting that Sparkle would hold any water. I can apply this to my life because I will know to buy Bounty a lot more often than the other brands, Sparkle and Brawny, since it holds more liquid. I can further extend this experiment by using weight on top of the liquid and also going further by testing out more brands. Sorry for any errors. I stutter a lot. Thank you.
My purpose. My topic is what nail polish will last longer. I chose this topic because some type of nail polishes don't last long, so by testing this you will know what is worth it to buy / what lasts longer. My question is, what nail polish lasts longer, shiny nail polish or matte nail polish? My independent variable is a different type of nail polish. My dependent variable is how long the nail polish lasts. And my control variable is how many layers you put. My hypothesis is if I use matte nail polish rather than gel / shiny nail polish, it will last longer because matte nail polish dries better on the nail, which doesn't cause it to chip easily like shiny nail polish does. My materials. There were not many materials used for this experiment, so these are the 2 materials that were needed: shiny nail polish and matte nail polish. My procedures. The first step is to paint 1 or 2 nails with the shiny nail polish. Step 2, on the same hand, paint 1 or 2 nails with the matte nail polish. Step 3, wait 10 minutes to let the nails fully dry. And step 4, next day, look at your nails, see if any of them chipped or not. And the last step is the next couple of days to see which one lasted longer and didn't chip as much. And here I have pictures of the matte nail polish and the shiny nail polish. Here I have my data table. I have the type of nail polish I used, which is the matte and the shiny nail polish. And I have my amount of days before chipping. The amount of days before my matte nail polish started chipping was about 5, and for my shiny nail polish, it was about 3. And here I just have it on a graph. So you can see it took 5 days for the matte nail polish and 3 for the shiny. In conclusion, I learned that matte nail polish lasts longer than shiny nail polish. Shiny nail polish chips after a while versus matte still chips, but shiny still chips faster, so matte lasts longer. I would like to thank and give credit to my teacher, Miss Rafferty, for explaining every step in detail so I would not be confused, or whenever I felt stressed on the way it was looking, she would give me some advice and give me a better understanding on the slides. Lastly, I would like to thank my mother for getting me the materials I needed to complete this project. And that is the end of my slideshow.
This is my science fair experiment. I'm Nadia's. Genetically modified organisms create glowing bacteria, and unfortunately, here's my acknowledgements. You can read that. I'm sorry. As I was saying, the screencastify thing only lets me record for 5 minutes, so I'm going to have to sort of skim through. So the purpose of this experiment was to see how the results of genetic modification varied with 2 different heat shocking times, 30 seconds and 60 seconds. And there were 2 trials. It required setting up the different plates, one for growing competent cells and the other for the actual transformation of the bacteria, growing these competent cells and then transforming them and allowing time for growth. The experiment results overall supported my hypothesis, with the 30-second heat shock producing more colonies in both trials. Though the experiment was imperfect, a few errors were made, it was also successful in the sense that I got bacteria to grow. So my question was, what amount of time heat shocking the E. coli bacteria would produce the most glowing colonies? And my hypothesis was that if the E. coli bacteria was heat shocked for 30 seconds, then there would be more glowing colonies on the agar plate. But forgive me for mispronouncing that possibly. So background information. This cloning refers to creating an exact copy of a small gene or piece of DNA as opposed to something larger. The transformation occurs when plasmids or other DNA are introduced into bacteria. And one key step of that is giving them a shock. For example, this heat shocking, which is just high temperature, to increase the odds of them taking up the foreign DNA. And these are my variables, materials. The procedure, in basic summary, was just create the plates using the way they showed you in the kit, and then grow the cells, transform them, including the heat shock, which is where the varying times came in, and then wait for the growth and count the amount of colonies. So my results, as you can see in both trials, overall, there were more growing colonies for 30-second heat shock than there were for 60-second. Here's it in bar graph form, just in case it's easier. And in conclusion, the evidence from my experiment did support my hypothesis, although I did make some errors. One example is that you had to be very careful when streaking the bacteria onto the plate. And I was trying to be careful, but I may have broken the surface, which was sort of like jello at times. Due to this, my experiment results may have not been the best possible, although research does show from outside sources, like the one I have cited there, that the hypothesis was still correct. And this was my first time performing an experiment related to genetic modification, but it helped broaden my view of science overall, which is great for my future. And a note that I may have forgotten to write there, a way to further this experiment would to be to add a third variable and do one, to do 3 trials, but two, I could also try doing 45 seconds because while the kit said 30 seconds, I found some sources that said 45 seconds would be a good heat shocking time, so I could try to see which one overall was better between the two. And I could also try different types of bacteria or different types of modification. And I'll go back to some slides that I may have skipped over if those weren't as easy to read since I somehow still have time. These was my dependent variable, which was the amount of colonies on the plate. The independent variable was the amount of time heat shocking it, and then pretty much everything else. And by that I mean, like, type of heat, location of the experiment, type of modification, the actual bacteria itself, that all remained the same. So that was my controlled variable, or controlling variables. And that is all I have for this experiment. Thank you. Whatever, I'll just end it.